Hi, welcome to Chapter 5, Lesson 2. This is annuity. Specifically, we're going to discuss simple and general annuity. So first, before we discuss computation parts, let us have the introduction to annuities. So annuities could be divided into two. We have annuity certain and annuity uncertain. So we will be focusing more on annuity certain. So under annuity certain, we have simple and general annuity. So under simple annuity, we have the simple ordinary annuity, simple annuity due, and we have the deferred annuity. For general annuities, we have general ordinary annuity, we have the general annuity due, and we have the perpetuities. So for general math lessons, we will further discuss and we will focus more on simple ordinary and general ordinary annuities. So how do they differ from one another? So when we say annuity, this refers to a fixed sum of money paid at regular intervals subject to a fixed compound interest rate. So annuity uncertain refers to annuity payable for an indefinite duration. So there is no specified duration for the payment of annuities. So for annuity certain, of course, it's the opposite. So this is payable for certain or definite duration. So simple annuity refers to annuities where the interest conversion or compounding period is equal or the same as the payment interval, while general annuity, in contrast, is a type of annuity where the interest conversion or compounding period is unequal or not the same as the payment interval. So, ordinary annuity refers to the periodic payment or an annuity where periodic payment is made at the end of each payment interval. Annuity due is when periodic payment is made at the beginning of each payment interval, while deferred annuity refers to a type of annuity where the periodic payment is not made at the beginning nor at the end of each payment interval, but some later date. For general annuity, the first payment is made at the end of every payment interval. General annuity due. So, first payment is made at the beginning of every payment interval, while for perpetuities, this is a series of periodic payments which are to run infinitely or forever. Now, let us have some definition of terms. The future value of annuity refers to a sum of the future values of all the payments to be made during the entire term. Present value is the principal that must be invested today to provide the regular payments. Payment interval refers to the time between successive payments. Periodic payment is the amount of each payment. Annuity is the fixed sum of money paid at regular intervals subject to a fixed compound interest rate. Take note, the interest rate for annuity is compound interest. Annuity certain, payable for a definite duration. Annuity uncertain, payable for an indefinite duration. So we've discussed these terms earlier in the graph. So we have simple annuity, interest conversion is equal or the same as the payment interval. Okay, so we've already discussed those in our previous diagram. So what are some examples of annuities? So we have the installment basis of paying a car, that's an annuity. When you're paying for an appliance in an installment basis. We have house and lot installment payments. So for example, if you're living in a subdivision and you're paying your monthly installment payments for your house and lot. And we also have life insurance and pension payments are also under annuities. So first, let us distinguish simple versus general annuity. So we have here some situations given. So determine whether it is simple or general annuity. Remember, when we say simple annuity, the payment interval and the compounding period is the same. So, first, Adora is preparing for an income fund for her retirement. She wants to receive 15,000 monthly for the next 25 years. The fund pays 10.5% compounded annually. So, payment is monthly and interest is compounded annually. Monthly and annually, not the same, so that means it's general. 2. A loan of 100,000 pesos must be repaid with equal monthly payments for 2 years. The money is worth 8% per annum compounded monthly. So, payment interval is monthly and compounding period is also monthly. So, they are both monthly, so that's why it is simple. Again, for general annuity, the compounding period and the monthly and the payment interval rather are not the same. If they are the same, then that's simple annuity. Let's proceed. Romana's parents save for his college education by investing 12,000 pesos at the beginning of each year in an education plan that earns 6% per year compounded annually. So that is payment is each year and annually. Take note, each year and annually are just synonymous or they just mean the same thing. So that is simple annuity. Next, Fernan borrows to buy a motorcycle. He will repay the loan by making monthly payments of 1,500 per month for the next 24 months at an interest rate of 9% per year compounded annually. So, payment is per month and compounding period is annually. Monthly and annually are not the same or not equal, so answer is general annuity. Next, Alex and Tony are twins. After getting a good job, Alex deposits 10,000 at the end of each year for 36 years. On the other hand, at the age 42, Tony deposits 20,000 at the end of each year for 18 years. Both annuities earn 12% per year compounded annually. So, we have here payment is each year, compounding period is annually. Each year and annually the same, so that is simple. Next, Hope borrows money for the renovation of her house and repays by making yearly payments of 50,000 pesos at the beginning of each year for a period of 10 years at an interest rate of 8% compounded annually. So, that is yearly and annually the same, so that is simple. Next, Mr. Samson bought a brand new car for 500,000 down payment and 20,000 every first day of each month for 3 years. Payments are based on 8% compounded semi-annually. So semi-annually is twice a year. So compounding period is semi-annually and payment is each month. So they're not equal, so that's general annuity. Next, 25,000 will be invested in an account at the end of each year at 4% compounded semi-annually. So, semi-annually and each year not the same, so that's general. Okay, last two examples. The latest cell phone sells for 5,000 down payment and 900 pesos at the end of every quarter for 3 years at the rate of 8% compounded semi-annually. So payment is every quarter, so that's every 3 months. And semi-annually is twice a year, so not the same. So that's general. And then, Emmy wants to save 100,000 pesos for her first year in college. She deposits 3,500 at the beginning of each month in an account that earns 4% per year compounded semi-annually. So, semi-annually and each month are not the same, so this is a type of general annuity. So, I hope you can now distinguish simple versus general annuity. Let's now proceed to the computation part. Now, as I have said, we'll only focus on simple ordinary and general ordinary annuities. However, I will still present to you the formula for simple annuity due and general annuity due. So first, let's have simple ordinary annuity. So we have here the given formula. Kindly take note of the formula given. So we have here some examples. So, Alex and Tony are twins. After getting a good job, Alex deposits 10,000 pesos at the end of each year for 3 years. On the other hand, at age 42, Tony deposits 20,000 at the end of each year for 18 years. And question, who will have a greater amount at the retirement if both annuities earn 12% per year compounded annually? Second problem, Fernan borrows to buy a motorcycle. He will repay the loan by making monthly payments of 1,500 per month for the next 24 months at an interest rate of 9% per year compounded annually. How much did Fernan borrow? So for the first example, we have Alex and Tony. So this is a simple ordinary annuity because they are paying at the end of each payment period. So, first, for Alex. So, this time, we are looking for the future value or FV. So, because we're trying to look for the amount after a certain period of time, or this, we have after 36 years and after 18 years for Alex and Tony respectively. So, for Alex, his principal amount is 10,000. Then, time is 36 years. So, rate is 12% or that is 0.12 in decimals. And K is your compounding period. So, that's 1 because it's only for compounded annually. So, future value is P times 1 plus R over K raised to T times K minus 1 over R over K. So, we substitute each of the amounts in our given formula. So, P is 10,000. We have 1 plus R is 0.12. K is 1. And we have time is 36 years because we have 36. Then, times 1 because K is 1. Minus 1 over 0.12 divided by 1. So, simplify, that will be 10,000 times 1 plus 0.12 raised to 36 minus 1 all over 0.12. So, we have 10,000 times 1.12 raised to 36 minus 1 over 0.12. So, please do not round off your answer for each of these expressions. So you have to continuously multiply or you have to continuously use the exact value. So the exact amount will be 4,844,631 pesos and 16 cents. So that means that Alex will have 4,844,631 pesos and 16 cents after 36 years of depositing 10,000 each year with 12% interest compounded annually. For Tony, we have P will be 20,000. Okay, we have here 20,000 for Tony. T is 18 years. R is 12% or 0.12 and K is equal to 1. So, again, we use the same formula and we substitute our values. So, we have 20,000 times 1 plus 0.12 over 1. So, raised to 18 times 1 minus 1 all over 0.12 over 1. So, simplify. Okay, sorry, this will be, there's no 20,000 here. Okay, so this will be, please disregard this amount, this one. Disregard this. So, this will give you 1,114,994 and 30 cents. So that means Tony will have 1,114,994 pesos and 30 cents after 18 years. So if you try to look at this, even though that Tony doubled his amount, okay, deposited, but Alex has deposited ahead of time. So, Alex will still have more amount or a greater amount at retirement. So the value of this is you have to save up early because time is more beneficial when you are investing for whether you're saving up for retirement or you're saving up for whatever purposes. So this time, Alex has a greater amount after a certain period of time. Second example. So, for this example, we have Fernan. Okay. This time, okay, we're looking for how much is the amount that Fernan borrowed. So, we're looking for the present value. Okay? So, P here is 1,500. R is 9% or 0.09. Time is 24 months or that's 2 years. And K is 12. So, 12 because we have here, he is making monthly payments. Okay? Monthly payments. So, that's 12 payments per year. So, we use our formula. Then we substitute each of these given in our formula. So that's 1,500 for P. R is 0.09. We have 2 years for the time. So this will give you, okay, we continue to simplify. This will give you 32,833 pesos and 72 centavos. That would mean that the total amount that Fernan has borrowed is 32,833 pesos and 72 centavos. So these are the formula for simple annuity due. Again, as I have said, we will focus only on ordinary annuity. So let's proceed. Okay, here are some examples for simple annuity due, and let's proceed to general ordinary annuity. So we have here the following formula for present and future value in general ordinary annuity. So some examples. The latest cell phone sells for 5,000 pesos down payment and 900 pesos at the end of every quarter for 3 years at the rate of 8% compounded semi-annually. Find the cash equivalent of the phone. Second example, 25,000 will be invested in an account at the end of each year at 4% compounded semi-annually. Find the size of the fund at the beginning of the 16th year. So for number 1, this is actually, okay, looking for the cash equivalent. So first, what do we know? We know that P is 900 pesos. Rate is 8% or that's 0.08. Time is 3 years. So K is 2 because there are 2 compounding periods for semi-annually. Every semi-annually. Okay, C here is 6 months for semi-annually. A is 3 months for every quarter. Okay, we have here, this is for the payment. And we have our PV. So, this is PV or present value because as I have said, we're looking for the cash equivalent of the cell phone. So, substitute each of the values in our formula. So, P is 900. We have R here is 0.08. T is 3. K is 2. We have A is 3 and C is 6. So this will be 900 times 1 minus 1 plus 0.08 over 2 raised to negative 3 times 2 all over 1 plus 0.08 divided by 2 raised to 3 over 6 minus 1. So, simplify, 0.08 divided by 2, that's 0.04. 3 over 6, that's 0.5. So, negative 3 times 2, that's negative 6. Okay, then further simplify. Okay, that will give you 9,529.28. But that is not yet the cash equivalent of the phone. That is just the present value for the payments for every quarter. So the cash equivalent or CE is equal to the down payment plus the present value. So that is down payment 5,000 plus the present value, which is 9,529.28 cents. So this gives us 14,529 pesos and 28 centavos. So therefore, the cash equivalent of the cell phone is 14,529 pesos and 28 centavos. Next example. 25,000 will be invested in an account at the end of each year at 4% compounded semi-annually. The size of the fund, or we have to find the size of the fund at the beginning of the 16th year. So this means that P is 25,000, R is 0.04 or 4%, T is 15 years because beginning of 16th year, that means 15 years has already been finished. C is 6, A is 12, and K is 2. 6 because we have 6 months for semi-annually. A will be 12 because we have each year, that's 12 months. And K is 2 because semi-annually would give you 2 payments in a year. So, this is our formula for the future value. Substitute each of the given numbers or values in our formula. So, we will have 25,000 times 1 plus 0.04 over 2 raised to 15 times 2 minus 1. Then we have all over 1 plus 0.04 over 2 raised to 12 over 6 minus 1. So, simplify. 0.04 divided by 2, that will give you 0.02. 15 times 2 is 30. Okay, so 12 over 6 will give you 2. Then, further simplify, you will get 502,080 pesos and 19 centavos. So that would mean that the fund size at the beginning of the 16th year will be 502,080 pesos and 19 centavos. So these are the formula for general ordinary annuity, or rather general annuity due. And we have some examples. Okay, so that's all for annuities, for simple and general annuities. I'll see you again in the next lesson. Bye!